Hello guys, welcome back to my channel Math Squad. So in this video we are seeing the theorems which are given before 1.3 exercise 1.3. Okay, so in this exercise or in this theorems we will deal with the decimal expansion of rational numbers. We know rational numbers are the numbers which can be written in the form of p by q, right? If we divide this p with q, then there are two possibilities. Then the decimal expansion is terminating and second is non-terminating, repeating. Let's see what is terminating. Terminating means the decimal expansion ends at a certain point. Okay, say for example, if I am dividing if my number is 11 by 2, rational number is 11 by 2, then let's see the decimal expansion of this. Let's divide with 2. 2 5s are 10. Then the remainder is 1. I'll put point here and take 0 here. Then again 5, 10, remainder is 0. 11 by 2 decimal expansion is 5.5, which is terminating. This is terminating. Okay, it ended at a certain point. Okay, let's see non-terminating and repeating. For non-terminating and repeating, I'll take 10 by 3. Okay, now I'll divide 10 with 3, then 3 3s are 9, again 1, I'll put a point here, 0, again 3, again 9, 1 reminder, I'll take 0, 3, 9, 10. This process goes on 3.333 and so on. 10 by 3 is equal to 3.33333 and so on. This number is non-terminating, which means it is not going to end at any point. That if you try to divide 10 with 3, the number will be 3.33333 and so on. Okay, that number is non-terminating. It is not going to end anywhere. Such numbers are called non-terminating. Repeating, of course, repeating means this 3 number is keep on repeating, no? So that is repeating. Decimal expansion of any number p by q can be of two forms, terminating and non-terminating. Okay, you understood? Then let's see the next theorem. Theorem 1.5. This theorem says that let x be a rational number whose decimal expansion terminates. Terminate means it will stop at a point. Okay, then x can be expressed in the form of p by q, where p and q are co-prime, and prime factorization of q is in the form of 2 power n and 5 power m, where nm are non-negative integers. Okay, what they are saying is, if you have a rational number x, suppose my rational number is x, then x I can write in the form of p by q, and if my q, and first they are saying is, if my rational number is, if the decimal expansion of my rational number is terminating, if x is terminating, then the denominator q will be in the form of 2 power n 5 power m, where nm are non-negative integers. They can be 0 also. Okay, sometimes n can be 0, sometimes m can be 0. Okay, if x is terminating, then the number p by q will be in the form of 2 power n into 5 power m, right? So let's see this example. Okay, let's check this if it is terminating or non-terminating. So 3 by 8, I'll try to write it in the form of 10 powers. I'll try to write my denominator in the powers of 10 so that my division would be easy. First, I'll write a prime factorization of 8. Prime factorization of 8 is 2 cube, that is equal to, now since I'm trying to make my denominator in 10 powers, I'll divide this with 5 cube by 2 cube into, I'll multiply and divide with 5 cube. Okay, if I cancel 5 cube, I'll have the same number, no, 3 by 8. Then 3 into 5 cube is 125 by 2 cube is 2 into 5 into 2 is 10. So this I can write it as 10 cube, that is equal to 125 into 3 is 5 3 is 15, 3 2 6 7 and 375 by 10 cube. This I can write it as 0.375. Since it is 10 cube here, I'll take my decimal before 3 places. Okay. So this is terminating. Okay. Here, since you have 2 power n, 5 power m, it is in the form of 2, the denominator is in the form of 2 power n, 5 power m. So that is the rational number 3 by 8 is terminating. Okay. Now let's check with this number 13 by 125. 13 by factorization, prime factorization of 125 is 5 cube. That is equal to, since I'm trying to make the denominator in the powers of 10, I'll multiply and divide with 2 cube. 5 cube into 2 cube. That is equal to 13 into 8 by 10 cube. 13 8s are 8 3s, 24, 8, 9, 10, 104 by 10 cube. This also I can write it as 0.104, which is terminating. Okay. So any rational number x is terminating when the rational number p by q, the denominator q is in the form of 2 power n, 5 power m. Okay. We'll see the next theorem. Oh, before going to see this, there is another number here, no, 7 by 80. You can try this by yourself, okay? Whether this is terminating or non-terminating, you can check it by yourself. Next theorem. Next theorem says that let x is equal to b by q be a rational number such that the prime factorization of q is in the form of 2 power n, 5 power m, where n and m are non-negative integers. Then x has decimal expansion which terminates. This is exactly the converse of previous theorem, no? So now here they are saying that x is a rational number, and if q is in the form of 2 power n, 5 power m, then the number, the decimal expansion of x terminates. Okay. If q is in the form of 2 power n into 5 power n, then the decimal expansion of x terminates. Then next theorem. Let x equal to p by q, where p and q are co-primes, be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating. Repeating means recurring. Repeating means the same number or numbers will be repeating. Okay. Here what they are saying, if prime factorization of the denominator q is not in the form of 2 power n into 5 power m, then x is non-terminating. Right? So here we have one example over here, 7 1. Let's divide 7 1 with 7. So I'll take 0.0. 7 ones are 7. 3 7. I'll take 0 here. 7 4s are 28. 2 7 2s are 14. 7 6. 7 5 35, some 6 42, 7 7 49, 7 8s are 56, then 4, 7 5s are 35, then 5, 7 6 are 42, 7 7s are 49, then 1, 7 1s are 7, 3. See, can you observe this? We started with the number 10 and again we got the number 10. So the numbers are going to repeat. It will be 142,857, again 142,857, again 142,857. This is 0.142,857. This is repeating. Okay, non-terminating and repeating. This this will not stop anyway. This will keep on going. Okay, the decimal expansion is non-terminating for the number 1 by 7. So what we understood, if a rational number p by q, if the denominator 7, okay, let's try to write this in the form of the denominator in the form of 2 power n and 5 power n. Suppose you 2 square into 5 square, I am multiplying and dividing with 2 square into 5 square, then 5 to 10, 10 4s 40, 5 40 into 7, 7 4s 280, or here I will have 2 square into 5 square. 2 square into 5 square is okay, but 7, I don't want this extra number. No, since I have an extra number, I cannot write my q in the form of 2 power n into 5 power m. So since I cannot write denominator in the form of 2 power n into 5 power m, the number 1 by 7 is non-terminating and repeating. Okay, so what we have learned in this video, first theorem is, if our rational number x is in the form of p by q, then if x is terminating, then q is in the form of 2 power n into 5 power m. Second theorem is just reverse of that. If our rational number is x equal to p by q, and if our denominator q can be written in the form of 2 power n into 5 power m, the number x, the decimal expansion of the number x is terminating. Then the last theorem says that if the denominator q in a rational number p by q cannot be written in the form of 2 power n into 5 power n, the rational number x is non-terminating, repeating. Okay, so we'll use these theorems to solve the problems in the next exercises. So that's it for this video. I'll see you in next session. Until then,